Welcome, students, and now we're getting into finishing up this ellipses. Basically, we're going from a graph to the equation, just writing it backwards. Now, be sure that you're printing the notes that are provided on PowerSchool, and do understand that, oh, dang it, this is the equation of an ellipse. Again, I'm hoping at the end of the school year, maybe the last 2 weeks, we could actually do, just like I'm trying to fix this too here, I'm messing everything up. We can actually do a project and actually create a bubble wand. And hopefully the weather will be nicer than what it is right now, very cold for May actually. And make sure you know the equation of a circle, an equation of ellipse. We have one more equation of a hyperbola, and we'll get into that very shortly. All right, so the first question here, and I'm planning on doing two problems here, question 1 and question 4. So if you look at this first one, write the standard form, and this is the standard form they want. I should have wrote in the if the center changes, but the center doesn't change on this one. If the center does change, we have to put x minus h squared over a squared and y minus k squared over b squared equals 1. So definitely know the difference there. This one, the origin is at 0, 0, and this one, the origin is shifted. It's either left or right, up and down, just moves. All right, so the origin on this one is obviously at 0, 0, so I am going to use this equation. It looks like it goes left and right 8. It looks like it goes up and down 6. And that's really all I need for the problem is going to be 8 squared plus y squared over 6 squared equals 1. Now, I'm going to assume that my math lab does not want, let me write that as a fraction, does not want the squared in there. So I'm going to go ahead and write that as 64. Let me see, there's y squared, and then put the fraction over 36. Equals 1, which is the standard form. Check my answer, there's my solution. It does want the foci, and we did that on the previous problem. So if you remember the foci, it was always the larger value minus the smaller value there. So in this case, it's going to be 64 minus, wow, that's a minus, that's an equal. And if you subtract those, let me see here, 64 minus 36, you get 28. Now, the problem with 28, well, I don't want to do square root yet, is that whenever I do take the square root, it's going to become 4 times 7, square root of 4 times square root of 7, which is going to be 2 square roots of 7. So the type of locations of the foci. Now again, the foci, since I haven't really moved the center or anything, those are the x values. I have a positive and a negative, so 2. Let me get the square root symbol in there, 7. There's the first one. Just make sure you get a comma in between 2 square root. Oh boy, there's a lot of typing in these. And there's the solution. All right, like I said, I was going to jump to question 4 and look at that last one. As you can see, that only took me about 3 minutes there to finish up. Let me scroll this up so I have a little bit of room to write. Now, the problem with this last question, I'm actually going to look at this. They give you the foci and also the vertices. And so what's happening here, they give you the vertices, and the vertices tell you if it's going left and right or up and down. So in this case, that's the vertices. And then just inside here, the foci is at 7 and negative 7. Wow, that's a negative 7. And so basically they're wanting us to write an equation. I have no idea how high and how low this graph gets. Well, if you remember the equation we just used, this actually finds the foci for us. So if you look at this, now let me go ahead and write the equation that I know so far. The center is going to be at 0, 0, because you can see it's moved over 8 this way, moved over 8 this way. It's equal distance, so that the origin is going to be at 0. This will be 8 squared, which is 64, since it's going left and right, plus y squared, again, origin's at 0, 0. And this is the only thing I don't know. I don't know the b value, so it's kind of nice. A lot of things are given to me. The c value is the foci. The a value is the main vertex, and then the b value is like the minor vertex, the smaller vertex, what I don't know here. So if I actually set that up, it'll be 7. Oh, let me rewrite that. 7 equals 8 squared, squared minus b squared, and actually solve this out like an algebra problem. Just a sec here. I don't need. Let me see. Get rid of that. All right. So now as I solve this, and again, just don't forget the squared. Don't forget the squared on both of those. That will be 49. That will be 64. Subtract that over. So let me subtract that over real quick with my calculator. 49 minus 64. It's going to be a negative answer, negative 15. But this is negative b squared. So I can actually just eliminate the negative on both sides. To get rid of the negative there, it's just going to be the square root of 15. Now it's nice having a square root because whenever I plug it in for b here, the b value, it says b squared. The squared and the square root will do what to each other? Just cancel out. So let me go ahead and type in everything. It's like I'm not inside there. I don't believe there. There it goes. X squared over 64. I think I typed everything in wrong. X squared over 64. There, that looks better. Plus y squared over 15. It's nice. I don't have to write the square root of that part, and then that should check out for my answer there. Again, if you have any questions or concerns, I am available on Zoom and meetings sometimes, so definitely get a hold of me. This problem is probably be the hardest problem that we're going through right now here with ellipses. Hyperbolas are very similar to ellipses. Instead of going inward, they just go outward, so we'll talk about that next week. And we do plan on taking a quiz next week, and then the final weeks, the last 2 weeks of the school year, the week of the 18th and the week of the 25th, we will be working on a project. I'm hoping that you guys will enjoy it where you're creating your bubbles. Oh, where it is. Bubble ones. And maybe the juniors, when they come back in the fall semester, maybe we can have a party and go outside and actually start off the school year that way. All right. Have a good day.